Okay, hello Cloud Gurus and welcome to this lecture where we're going to continue our look at the Google Cloud Developer cheat sheet. Like before, please try to follow along on your own copy of this document. It's useful for you to get familiar with it yourself. Now, before we jump in, let me reassure you that I am not going to read out and talk about every line on this document. My purpose here is to give you a feel for the different products that Google Cloud offers, and to give you a bit of a heads up on some of the ones that you're going to come across. Truth be told, there are some items on this list that you will never have to deal with in your entire life. Now, I'm not going to be able to list those items because it's going to actually be different for different people. But I want to talk a little bit about the ones that you are likely to deal with and let you know that the text version of this document links out to the documentation for every single one of these products. In fact, most of them have two links. One link goes to the more marketing type, everyone-friendly version of the documentation that describes the product, why you might want to use it, what it does, stuff like that. And the other link goes to the developer documentation, where you can learn all the details that you need to know to be able to use that particular product effectively. But let's start at the top of the list. Compute Engine is described as Virtual Machines Disks Network. This is the most relatable Google Cloud product. Just like computers you might buy from the store, you can run whatever you want on them, do virtually anything with them, but you rent these ones by the second. Have a huge job? Maybe spin up dozens, hundreds, or even thousands of Compute Engine instances at the same time to get the job done faster. Then stop paying for them when the job's done. This is like the workhorse 2x4 brick of the Lego world. You can build almost anything with it if you have the time and you're okay with having a few rough edges. But in terms of building systems, this is a relatively small brick where you have to do a lot of work yourself to use it. Cloud Functions, just a little way down, is described as event-driven serverless functions. Cloud Functions is built even finer grained than Compute Engine is. This is by the 10th of a second, but it manages all of the scaling for you automatically. This is Google Cloud's Functions as a Service product, or FaaS, and just like Amazon's Lambda, this is a key building block of serverless systems. With this, instead of running server programs that sit around and wait for clients to connect to them, in Cloud Functions, you set up an event, and Google will run the code that you've given it every time that event happens. If no events are happening, you're not paying anything. And if a whole bunch of these events happen all at the same time, then Google just runs your code in parallel, lots of times. But you don't even really have to think about that. Google just does it automatically. Now, there are all sorts of events that you can hook up. They could be requests through HTTP, like connections being made from your web page or other microservices or something like that. Or the event could be a new object being uploaded to cloud storage, or a message being sent to Cloud PubSub, or any number of other things really. There are lots of different event types. Now, this isn't a perfect comparison, but if we were looking for something in the Lego world that would be like this, maybe it would be like a thin 1x6 brick. You can build lots of things with it, but it's particularly good at connecting all sorts of things together. Now, speaking of cloud storage, just like Cloud Functions, Cloud Storage is also a serverless product, and they work very nicely together. Cloud storage is like the most pure service at its core. It says, give me some data, and I can give it back to you. No fuss, no muss, and incredibly reliable. You never really change any data it holds, but you can give it some new data and tell it to forget about the old stuff. But unless you tell it to, it's really, really good at not losing your data, and it's also amazing at handling however much load you slam it with, without even breaking a sweat. That's why it's described as object storage and serving. Nearline and Coldline are really just versions of cloud storage that are priced and optimized for less frequent data access patterns, so they're perfect for backups. That's why their descriptions are archival occasional access storage and archival rare access storage. Persistent disk is a special kind of storage, and its description gives that away. VM-attached disks. Now, the cloud storage product is object storage, but persistent disk is block storage instead. So it works much like a hard drive does, and it only connects to compute engine instances. In a way, persistent disk is kind of like the Lego pieces with a different kind of connector on the side. It only goes together with compute engine. They were made for each other. You don't usually even think too much about the persistent disks. They're just one aspect of the compute engine instance. But if you've decided to take on the burden of managing data storage yourself, which I don't generally recommend, by the way, then you'll get more familiar with this product and some of the cool things that it can do beyond what a normal hard drive could do. Cloud File Store sits between cloud storage and persistent disk, and it is neither object-based nor block-based. Cloud File Store is file-based. Being a managed NFS server, it's a bit more flexible to connect to than persistent disk, and may work better with certain kinds of applications than the object-based cloud storage. Jumping back up a little bit, GKE, or Kubernetes Engine, can help alleviate some of the management burden that you would otherwise have to deal with Compute Engine. GKE will install, run, and manage Kubernetes for you on clusters of Compute Engine instances. But it also reaches out to the networking world and creates things like cloud load balancers, which helps reduce even further the amount of stuff that you would have to do. Now, Cloud TPU is listed in the AI and machine learning section, but it's specialized hardware for machine learning, so it's kind of like a compute engine instance, but this one is purpose-built for TensorFlow processing instead of for general-purpose processing. In fact, that's what TPU stands for, TensorFlow Processing Unit. Now, if you're not familiar with it, TensorFlow is an open-source platform for doing machine learning stuff. It's quite broadly popular, but it's actually another one of the things that Google originally created and then released as open source. Now, some of the products in the AI and machine learning section are pretty straightforward. Cloud Speech to Text will convert audio to text. Cloud Text to Speech will convert text to audio. Cloud Natural Language is for text parsing and analysis. So you can give it some text, and then it'll tell you both the parts of speech and the emotions that are represented in it, stuff like that. But there's a lot more breadth to the AI and machine learning products. In fact, there's quite a spectrum, where at one end you have the completely automatic, pre-trained machine learning model stuff, like we've just talked about. At the complete opposite end, we have Cloud Machine Learning Engine, which is a managed platform for machine learning, where it will run TensorFlow for you. Or if you want to get even more manual, the Cloud Deep Learning VM image is a pre-configured virtual machine for deep learning, so you would run that image as a compute engine instance. In the middle of the spectrum, though, we have the Cloud AutoML products, where the basic machine learning models are set up, but you can train them on your organization's own set of data, whether those be text documents or images or translations or what have you. The databases section has quite a variety of products. The one that's most likely to be familiar to you is Cloud SQL, which is managed MySQL and PostgreSQL. Here, instead of having to manage the compute engine instances and persistent disks yourself, and installing MySQL, upgrading it, applying patches, all that good stuff, here, Google can do all of that for you, and can even manage things like read replicas. But not everything fits within a single MySQL instance, and so Cloud Spanner is a horizontally scalable relational database. This thing is seriously massive scale, and it lets you keep all of the things you love about relational databases while still scaling well beyond what you would ever consider normal for that. But not every situation still needs a relational database, so there are a number of non-relational options too. Cloud Firestore, which incidentally shows up in a couple of sections here, since it's also one of the Firebase family of products that shows up in the mobile products section. It's a strongly consistent serverless document database, and it has some really cool things built in, like WebSocket connections for updates. But there's also Cloud Data Store, which is a horizontally scalable document database. And one of the nice things about Cloud Data Store is that you just pay for what you use. You don't have to provision and manage a certain capacity. But if you do have a more predictable and high volume, then Cloud Bigtable might be a better choice, since it is a petabyte scale, low latency, non-relational database. In the Data and Analytics section, two of the core services that stand out are Cloud Dataflow and Cloud Data Proc. Now, Data Proc is managed Spark and Hadoop. So if you're already running Hadoop work somewhere else, Cloud Data Proc could be a good way to move that work onto the Google Cloud. This is for processing large amounts of data, and it uses Compute Engine under the hood, just like Kubernetes Engine does. Cloud Dataflow also processes large amounts of data, but this is newer and better than Cloud Data Proc, and it handles both stream and batch data processing. The key technology behind Cloud Dataflow is something that Google released as the open source Apache Beam. Now, Google Genomics is very specialized, and it's only really useful if you're working with that kind of medical data. Comparing this to Lego pieces, this is kind of like a helicopter rotor Lego piece. It's not very general purpose, but it's very useful if you have that particular need. Cloud PubSub is probably the most flexible product in all of Google Cloud. This is described as global real-time messaging, and it can be used to connect almost anything to almost anything else. In Cloud PubSub, you create topics, and then you have one part of your system publish messages to that topic, and another part of your system subscribe to messages from that topic. So for example, you might have a cloud function that creates some data and publishes it, and then you might have that same data flow out to both Cloud Dataflow and BigQuery. Now, speaking of BigQuery, some people have described BigQuery as the crown jewel in Google Cloud. It is definitely a really important and valuable product. It's described as data warehouse/analytics, but I think that undersells it quite a lot. BigQuery is serverless in that when you're not using it, you're not paying for it, and then when you slam it with a huge, complicated SQL query, it just scales up automatically and handles it without a problem. You can store tons of data in BigQuery and still get incredibly fast responses to your queries. Pretty much everyone loves BigQuery. In the networking section, there are a bunch of different things listed. Virtual Private Cloud, or VPC, is the core. It's the umbrella for the software-defined networking, and most of the other networking services hang off of that one. You can use Dedicated Interconnect to have a dedicated private network connection between that VPC and your external data center. You can use Cloud NAT to have network address translation to connect out from that VPC. And you can have cloud load balancing that deals with multi-region load distribution into that global virtual private cloud network. Cloud load balancing is pretty special, especially when you combine it with the premium network service tier. That can let you have your clients, who are connecting from all over the world, connect to one single IP address and still have all of those connections be made to whatever server inside of your VPC is actually physically closest to them. That means that your clients can have much faster connections, and faster connections makes for happier clients. Oh, and it also handles situations where there isn't something close by to serve that request because it's failed or something like that, and it can just reroute that inside of Google's global network to some server that actually can still handle that request. But this is all transparent to the client, so failovers like that can happen almost instantaneously. Now there are more products here too. Cloud Armor is distributed denial of service protection and a web application firewall. Cloud CDN is a content delivery network that can cache data much closer to where users are physically located. And Cloud DNS lets you take advantage of Google's programmable DNS serving network, where their domain name system has a 100% uptime guarantee. When your users are connecting to mycoolwebsite.com or whatever it is, you definitely want that name translation to succeed. Otherwise, they won't be able to connect to your service at all. Down in the Management Tools section, Stackdriver is an important family of services. Stackdriver Monitoring is infrastructure and application monitoring, so you can watch metrics of what's going on in your system. Stackdriver Logging is centralized logging, so that all the different parts of your system, whether they be microservices or just multiple instances or completely different parts of your system, they can all log to one central place. Centralized logging is really important to running a system, because if you have to go out and try and gather up log information from every individual piece of your system just to make sense of what's been happening, you're going to get so bogged down in that overhead that you won't actually be able to make any progress. The Identity and Security section has a number of interesting products too. The core ones are Cloud Identity, which, if you're not using G Suite, is where you manage users, devices, and apps, and Cloud IAM, which stands for Identity and Access Management, is the resource access control part of things. Cloud IAM ties everything together from a security perspective. That's where you define who can do what to which things. Now there's more security-related stuff too, like Cloud HSM is the hardware security module service. You can use that to manage your encryption keys and certificates. And the Cloud Data Loss Prevention API is actually a machine learning service that can classify and redact sensitive data from what you pointed at. Now, I could go on like this all day, but I'm sure you'll be happy to hear that I won't. So feel free to keep reading through some of these on your own, and following up on some of the ones that interest you by taking a look at their product overview pages. A lot of these pages are really user-friendly, and some of them even have little demos built in. Well, alright, I hope you found that to be a valuable walk through some of the key products that Google offers to get a feel for how those products could be used to build bigger systems. If you have any questions about this, please let me know. If not, please feel free to move on to the next lecture. Thank you.